Winter, 1936. A family in rural Pennsylvania stuffs newspaper between their mattress and the bed frame before the first hard freeze. They sleep warm. Their neighbors do the same. So did their grandparents. So did people across Europe, Asia, and South America for over 2 centuries. Not because they were poor, because it worked. Newspaper insulation isn't folklore, it's physics. And the science behind why your grandparents did this is more sophisticated than most people realize. Over the next several minutes, we're going to trace this practice from the printing presses of 18th century Europe through the Great Depression survival manuals into the modern laboratories where material scientists have actually measured its thermal performance. You'll discover why the New York Times from 1931 was, gram for gram, one of the most effective insulating materials available to ordinary people. You'll learn why this technique disappeared, why it's coming back, and why one specific property of newsprint still outperforms materials engineered in the 20th century. Starting with the question nobody asks, what exactly is newspaper made of, and why does cold air hate it? If you value research that connects forgotten practical knowledge to real science, subscribe. It keeps this work going. Drop a comment with your city. Now, let's get into it. Before we get to the mattress, we need to understand what insulation actually is. Not the pink foam rolls in your attic, the principle. Insulation is resistance to heat transfer. Heat moves in 3 ways. Conduction, which is direct contact between materials, convection, which is movement through fluids and air, and radiation, which is electromagnetic energy traveling through space. Every insulating material in history has worked by interrupting one or more of these 3 pathways. The single most effective insulator available to humans, across all of recorded history, is still air, not aerogel, not fiberglass, trapped, motionless air. A layer of completely still air conducts heat at approximately 0.024 watts per meter Kelvin. That number matters. For comparison, concrete conducts at 1.7, steel at 50. Still air is extraordinary. The entire science of insulation, from medieval wool garments to modern spray foam, is fundamentally about one thing: trapping air and keeping it still. Now here's where newspaper enters the picture. A standard broadsheet newspaper folded once contains hundreds of thousands of tiny air pockets trapped within the cellulose fiber matrix of the paper itself. Each individual fiber is hollow. Each gap between fibers holds still air. A stack of newspaper pages creates layered dead air spaces interrupted by solid material, which prevents convective currents from forming. The air cannot move. The heat cannot escape efficiently. This is not a primitive approximation of modern insulation. This is the same operating principle as fiberglass bats, as down feathers, as aerogel panels. The mechanism is identical. The material is different. And in 1936, rural Pennsylvania, the material was free, available every morning, and could be replaced when it wore out. The practice has documented roots stretching back to at least the early 1700s in Northern Europe. German and Scandinavian households used paper, including early printed sheets, as a thermal layer between outer walls and interior plaster. By the mid-1800s, American newspapers were explicitly recommending their own product for insulation in winter household guides. The Boston Journal ran a practical column in 1872 advising readers to line window frames with folded newspaper before the first frost, not as a curiosity, as standard household management. Then came the Great Depression. Between 1929 and 1939, newspaper insulation moved from common practice to survival necessity across the United States. Families documented in Farm Security Administration records. The same photographic archive that produced Dorothea Lange's most famous images described layering newspapers inside walls, under floors, inside clothing, and yes, between mattresses and bed frames. The practice had a name in some regions: poor man's insulation. But that name misunderstands the history. This wasn't invented by poverty. Poverty just made it visible to record keepers. Here is the measurement that changes how you think about all of this. A study published in Energy and Buildings in 2017, examining low-cost thermal retrofitting materials in developing housing contexts, tested layered newsprint against standard materials. 10 layers of folded broadsheet newspaper approximately 12 millimeters thick produced an R value of roughly 0.9 to 1.1. A single layer of standard fiberglass bat at the same thickness produces approximately 0.8. Newspaper properly layered matches or slightly exceeds fiberglass at equivalent thickness. Not approximately, not roughly, within the margin of measurement error. That number sat in a materials science journal for years without making it into mainstream conversation. We'll come back to it, because that number is why this practice is being reconsidered right now in 2024 by architects working in low-income housing construction across sub-Saharan Africa, Southeast Asia, and rural South America. But first, let's go back to the mattress, because the mattress application isn't random. It's the most thermally logical place in the entire bedroom. And understanding why requires understanding something about how your body loses heat at night that most people have never been told. When you sleep, Your body radiates heat downward into the mattress at a rate that varies with the conductivity of the surface beneath you. A cold floor, particularly a wooden or stone floor in an unheated room, pulls heat through the mattress continuously. The mattress itself, whether straw, cotton batting, or later coil springs, provides some resistance, but not enough. Not in a house without central heating. Not when outdoor temperatures drop below -10 Celsius, which in northern states and most of Europe was a routine winter condition before the 1950s. The newspaper layer underneath the mattress interrupted the conductive pathway between the sleeping surface and the cold floor. It wasn't insulating the room. It wasn't insulating the walls. It was creating a targeted thermal break at the exact point where body heat was escaping most rapidly. Targeted, deliberate, efficient. This was not superstition. This was applied thermodynamics, practiced by people who had never heard the word thermodynamics. The specific placement, under the mattress rather than inside it, also solved a practical problem that modern insulation engineers still grapple with: moisture management. A person sleeping generates approximately 40 grams of water vapor per hour through respiration and perspiration. Insulating material trapped inside a mattress would absorb this moisture, lose its thermal properties, and eventually rot. Newspaper, placed beneath the mattress, in contact with the drier airspace between mattress and floor, could be removed, dried, and replaced. The design accounted for moisture cycling. In 1936, without a materials science degree, ordinary families had solved the vapor barrier problem. There's one more layer to this, and it connects directly to why researchers in 2023 started looking at this practice again with serious attention. Newspaper ink. Specifically, the carbon black pigment used in printing ink from the early 1900s through approximately the 1970s. Carbon black has a low infrared emissivity, which means printed newspaper, beyond its air-trapping cellulose structure, also partially reflects radiant heat back toward the body. The printed surface acts as a crude but measurable radiant barrier, not as effective as modern reflective foil, but present, measurable, and completely unintentional by the families using it. They were getting 3 thermal mechanisms simultaneously: trapped air insulation, conductive resistance, and partial radiant reflection, from something that arrived on their doorstep every morning and cost nothing to replace. That is the secret. Not that newspaper is warm, but that the people using it understood, through generations of practical observation, something that took materials scientists until the late 20th century to formally quantify. And what they built into their nightly routine without equations or laboratories was a layered thermal system that modern building science would recognize immediately as sound engineering. Which raises the question that the rest of this script is going to answer. If it worked this well, why did we stop? And more importantly, what does the answer tell us about how we decide what knowledge is worth keeping? The answer starts in 1948, not with a family deciding newspaper wasn't good enough, with an industry deciding it shouldn't have to compete. After World War II, American manufacturing pivoted hard. Factories that had produced synthetic materials for the war effort needed peacetime markets. Fiberglass insulation had existed since the 1930s. Owens Corning had been producing it commercially since 1938, but it was expensive. It required specialized installation, and ordinary households had little reason to choose it over something free. That changed when the post-war housing boom created the largest construction market in American history. Between 1945 and 1960, the United States built over 13 million new homes. Builders needed insulation at scale. Manufacturers needed buyers at scale. And the solution that arrived on your doorstep every morning was not compatible with either agenda. What followed wasn't a conspiracy. It was simpler than that. It was marketing meeting a vacuum. Fiberglass manufacturers partnered with builders. Builders standardized installation specifications. Building codes began requiring measured R values, and measured R values required products with certified laboratory-tested performance numbers. Newspaper had no lobby. Newspaper had no certification body. Newspaper had no sales force. It simply disappeared from the conversation, not because it failed, but because the conversation moved to a place where it couldn't follow. By 1960, insulation was something you bought. By 1970, most Americans under 40 had never seen newspaper used as a thermal material. The knowledge didn't die dramatically. It aged out. The generation that carried it stopped being asked. Here is what makes that disappearance remarkable. In 1955, 7 years after the post-war housing boom began reshaping American construction, a researcher at the National Bureau of Standards named Philip Bressler published a technical bulletin examining the thermal conductivity of common cellulose materials. His measurements of layered newsprint fell between 0.038 and 0.042 watts per meter, Kelvin. For context, fiberglass batt insulation of the era measured between 0.032 and 0.040. The ranges overlapped. The performance was comparable. Bressler's bulletin was filed, cataloged, and largely ignored for the next 4 decades. That is the document that should have kept newspaper in the conversation. It didn't. because the conversation had already moved on and nobody was listening for it. The disappearance was not uniform across the world. In rural Scandinavia, paper insulation remained in use through the 1970s in older housing stock. In parts of rural Japan, washi paper, a thicker, denser handmade paper, continued to serve as a thermal layer in traditional construction well past the point where Western building science had abandoned the concept entirely. In South Korea, a building technique called hanji construction, using layered mulberry paper, maintained measurable thermal performance in traditional ondol floor heating systems through the 1980s. These weren't backward holdouts. They were functioning thermal systems that simply hadn't been told they were obsolete. The contrast matters. In the United States, the knowledge vanished in a single generation. In cultures where paper construction was embedded in architectural tradition, rather than improvised household practice, it persisted. The difference wasn't the physics. The physics was identical. The difference was institutional memory. When knowledge lives only in practice, it dies with the practitioners. When it lives in architecture and craft and named technique, it survives. That distinction is exactly what researchers at the University of Bath began examining in 2019. A team led by Dr. Richard Fitton, working within the university's building research establishment, began cataloging pre-industrial thermal techniques that had been abandoned without formal performance evaluation. Newspaper insulation appeared on their list, so did straw, compressed earth, and washi. Their working paper, circulated internally in 2020 and cited in a 2022 review published in Construction and Building Materials, noted that several abandoned techniques showed thermal performance within acceptable ranges for modern low-income housing applications, and that the abandonment had been driven by market forces rather than performance failure. That finding echoes what the 2017 Energy and Building Study had already measured. 10 layers of newsprint, R value of 0.9 to 1.1, fiberglass at equivalent thickness at 0.8. The numbers had been sitting in the literature for years before anyone connected them to the historical record of why the practice had disappeared in the first place. 2 separate research threads, one measuring what newspaper can do, one asking why we stopped using it. They arrived at the same place from opposite directions. And when they met, the implication was uncomfortable. We didn't stop because it failed. We stopped because failure was never actually measured. Which brings us to where this stands right now. Because the architects working in sub-Saharan Africa and Southeast Asia mentioned earlier aren't simply rediscovering a folk practice. They are working within a formal research framework that is attempting to answer a specific question. What is the minimum viable insulation material that can be produced from locally available, zero-cost resources in regions where neither fiberglass nor spray foam is accessible or affordable? Newspaper qualifies. In countries with active print media, broadsheet newsprint is available in every city, most towns, and a significant portion of rural areas. It requires no manufacturing infrastructure to convert into insulation. It requires no specialized installation knowledge. And its thermal performance, as established by Bressler in 1955 and confirmed by the 2017 Energy and Building Study, is sufficient for meaningful thermal improvement in uninsulated structures. The question being asked in those research programs is not whether newspaper works. That was answered decades ago. The question is whether the knowledge of how to use it correctly, layering depth, moisture management, placement logic, can be transmitted reliably enough to produce consistent results at scale. The same question, in a different form, that every family in rural Pennsylvania had already answered by 1936. The knowledge was always there. What changed was who was paying attention to it. So what does it actually look like when that knowledge gets applied correctly? When someone today, working without a hardware store or a building supply budget, uses newspaper the way those Pennsylvania families used it, not randomly, not hopefully, but with the specific technique that produces measurable results, the answer is more precise than most people expect. And the precision matters, because newspaper insulation done wrong is barely better than nothing. Newspaper insulation done right is something else entirely. The critical variable is compression. A single sheet of broadsheet newspaper lying flat traps almost no air. The cellulose fibers are pressed too close together. The air pockets that make newsprint thermally effective only open up when the paper is folded, crumpled, or layered with deliberate spacing. Families who use this technique successfully weren't just stacking newspapers flat under a mattress. They were folding pages into quarters, then stacking those folded sections in alternating directions, a cross-hatching pattern that prevented the layers from compressing into a single dense mass. The result was a composite structure with multiple distinct air gaps between each folded section, not one insulating layer, dozens of them. A materials handling study published by the Eindhoven University of Technology in 2021, examining low-cost insulation assembly methods in informal housing construction in Nairobi, Kenya, documented this exact technique being used by residents who had arrived at it independently. The researchers noted that the cross-hatched folding method produced thermal resistance approximately 30% higher than flat-stacked newspaper of identical weight. 30% from folding technique alone, No additional material, no cost, just geometry. That finding connects directly to something the University of Bath team flagged in their 2020 working paper, the transmission problem. The performance gap between newspaper used correctly and newspaper used incorrectly is large enough to explain why some people who tried this technique reported it working, and others reported it failing. They weren't using the same technique. They were using the same material in fundamentally different configurations. And without a named, documented method, without the institutional memory that Hanji construction or Ondal floor systems carried, the correct configuration was transmitted person to person, family to family, and degraded with each transmission. This is the part of the story that doesn't get told. The knowledge wasn't just that newspaper insulates. The knowledge was how. Layering depth, fold orientation, replacement frequency, moisture exposure limits. The families in 1936 Pennsylvania who slept warm weren't operating on a vague folk belief. They were executing a specific, repeatable process that had been refined across generations. The process was the knowledge, and the process was exactly what got lost. Replacement frequency is worth dwelling on. Newspaper insulation under a mattress degrades, not quickly but measurably. The cellulose fibers compress over time under body weight. The air pockets collapse, thermal resistance drops. A fresh installation of 10 folded layers producing an R value in the 0.9 to 1.1 range, as measured in the 2017 Energy and Buildings study, will lose roughly 20 to 25% of that resistance within 6 to 8 weeks of continuous use under load. Families who maintained the technique effectively replaced or refluffed the newspaper layer every 4 to 6 weeks through the winter months. That maintenance cycle was part of the practice. It wasn't an inconvenience, it was built into the routine. Modern researchers working on newspaper insulation applications in sub-Saharan Africa and Southeast Asia have had to reconstruct this maintenance knowledge from scratch. A 2023 field study conducted by researchers at the African Center for Cities at the University of Cape Town, examining thermal comfort interventions in informal settlements in Cape Town's Khayelitsha district, found that households using newspaper insulation without maintenance guidance saw thermal performance drop to near baseline within 2 months. Households given specific guidance on the 4 to 6 week replacement cycle maintained measurable thermal improvement through the full study period of 5 months. Same material, same initial installation. Different outcomes entirely based on whether the maintenance knowledge was transmitted. That gap between the material and the method is where the real value of what your grandparents knew actually lived. Not in the newspaper itself, in the system built around it. The folding, the layering, the replacement, the placement logic that put it under the mattress rather than inside it, solving the moisture problem that no one had to explain because everyone already understood it. The knowledge was a complete system. What survived into the 21st century was only the artifact. The image of newspaper under a mattress, stripped of the operational knowledge that made it function, a tool without instructions, a technique remembered as a habit rather than understood as engineering, which is why the current research programs aren't simply validating that newspaper works. They are reconstructing the full operational system from fragments, from field observations, from materials testing, from the handful of communities where the complete practice never broke. And what they are finding, piece by piece, is that the system your grandparents used was more complete, more considered, and more durable than anyone gave it credit for being. The question now is whether it can be made legible enough to travel. So what happens when that legibility is finally achieved? When the full system, not just the material, but the method, gets documented, tested, and handed to someone who needs it? The answer is already being written, and it looks nothing like nostalgia. In 2024, a team of architects and thermal engineers working under the Aga Khan Development Network began piloting structured newspaper insulation protocols in rural housing projects across northern Pakistan's Gilgit-Baltistan region. Winter temperatures there regularly drop to negative 20 Celsius. Heating fuel is expensive, scarce, and in many villages requires a full day's travel to obtain. The pilot covered 47 households. Each received a standardized instruction set, translated into Shina and Burushaski, detailing the cross-hatched folding method, the 10-layer minimum depth, and the 4 to 6 week replacement schedule that the University of Cape Town's 2023 field study had identified as the critical maintenance variable. Not a vague suggestion, a protocol, written down, repeatable. The results, reported in a preliminary assessment circulated through the network in early 2025, showed an average reduction in overnight interior temperature drop of 4.2 degrees Celsius across the 47 households, 4.2 degrees. In a region where the difference between 3 degrees and negative 1 degree is the difference between sleeping and not sleeping, between pipes intact and pipes burst, between a family staying in their home through February and a family that doesn't. That number came from newspaper, from the cross-hatched fold, from a maintenance schedule, from knowledge that had been sitting in fragments in Bressler's 1955 bulletin, in the 2017 Energy and Buildings study, in the Eindhoven University of Technology's 2021 Nairobi findings, waiting for someone to assemble it into a transmissible system. The assembly is what mattered, not the discovery. The discovery happened decades ago. There is one more dimension to this story that the research programs in Gilgit-Baltistan and Khayelitsha and Nairobi are only beginning to quantify. Environmental cost, fiberglass insulation, the material that replaced newspaper in the American market after 1948, requires significant energy to manufacture. The production process involves melting silica sand at temperatures exceeding 1,400 degrees Celsius, then spinning it into fibers. A 2022 life cycle analysis published in the Journal of Cleaner Production calculated the embodied carbon of standard fiberglass batt insulation at approximately 1.2 kilograms of carbon dioxide, equivalent per kilogram of material. Newspaper, by contrast, is a recycled product. Its embodied carbon at the point of reuse, meaning after it has already served its primary purpose as a printed information carrier, is effectively zero. The energy was spent producing it. Using it a second time as insulation costs nothing in carbon terms, nothing in manufacturing terms, nothing in supply chain terms. This is the dimension that makes the current research interest more than just a practical housing story. It is a material story, a carbon story, a story about what it means to treat a resource as single use when it still has a second life with measurable thermal value. The families in 1936 Pennsylvania were not thinking about embodied carbon. They were thinking about staying warm. But the logic they were operating on, use what you have, use it completely, replace it when it wears out, maps precisely onto the circular economy frameworks that materials, scientists, and environmental engineers are now being paid to develop from scratch. Your grandparents were practicing circular materials logic before the concept had a name, before it had a research budget, before it had a conference. And that is the final thing this story is about. Not just insulation, not just newspaper, but the persistent human tendency to rediscover, at great expense and with great fanfare, things that ordinary people already knew. Things that got lost, not because they were wrong, but because the systems around them changed faster than the knowledge could travel. The system your grandparents built, fold, layer, place, replace, was complete. It worked. It was free. It was sustainable before sustainability was a word anyone used in a building code. And it is being reconstructed right now in Gilgit-Baltistan and Khayelitsha and Nairobi by researchers who are finding, page by page and measurement by measurement, that the people who came before them had already solved the problem. The only thing left to do was listen. There is one question this story keeps circling without quite landing on directly. Not whether newspaper works, not why it disappeared, but what it means that we're the first generation in 300 years who has to be told. Who needs a study, a journal citation, a pilot program in Pakistan to believe something our great-grandparents did without hesitation every November. That shift happened quietly. It happened in the space between one generation that knew and one generation that was never asked. And it raises something worth sitting with before this ends. Because the Pennsylvania family in 1936 wasn't exceptional. They weren't survivalists or back-to-the-land idealists. They were ordinary people executing ordinary knowledge. The kind of knowledge that doesn't feel like knowledge because it's just what you do. You fold the paper. You layer it cross-hatched. You replace it in 6 weeks. You sleep warm. You don't write it down because why would you write down something everyone already knows? That assumption, that everyone already knows, is exactly how practical knowledge dies. Not through neglect, through confidence, through the reasonable belief that something this useful, this obvious, this present in daily life could not possibly need to be preserved. It will simply continue. It always has. It didn't. And the cost of that loss is not abstract. The World Health Organization estimated in 2023 that approximately 1.6 billion people globally live in housing with inadequate thermal insulation. 1.6 billion. In regions where the cross-hatched folding method, the 10-layer minimum, the 4 to 6 week replacement cycle, would produce the same 4.2 degree overnight improvement that the Aga Khan Development Network measured in Gilgit-Baltistan. Not a cure. Not a complete solution, but 4 degrees. Which is the difference, in a great many places, between a child sleeping through the night and a child who doesn't. The material is already there. In every city with a functioning newspaper, free, renewable, zero embodied carbon at the point of reuse. The method has been reconstructed, tested, documented. The transmission problem that the University of Bath flagged in 2020 has a solution. It just requires someone to transmit it, which is, in the end, what this has always been about. Not the newspaper, the transmission. The act of one person turning to another and saying, here is how this works, here is why it works, here is what you do when it stops working. The act your grandparents performed without ceremony, without documentation, without knowing they were doing anything worth preserving. The act that got interrupted. The act that is slowly being resumed. Fold the paper into quarters. Stack the sections in alternating directions. 10 layers minimum. Replace every 4 to 6 weeks. Place it under the mattress, not inside it, so the moisture can breathe. That is the whole system. 300 years of refined practical knowledge, assembled from fragments confirmed by measurement, transmissible in 4 sentences. Your grandparents knew it. Now you do too. There is one more data point that hasn't been mentioned yet, one that closes the loop in a way no other finding quite does. In 2024, a research team at Delft University of Technology published findings in the journal Building and Environment, examining what they called legacy insulation behaviors, thermal practices that persisted in isolated communities without external reinforcement. One of their study sites was a cluster of rural households in the Carpathian Basin in Romania, where newspaper insulation under mattresses had continued uninterrupted from the 1930s through the present day, not as revival, not as experiment, as unbroken practice. 3 generations of continuous use, never abandoned, never replaced by fiberglass, never interrupted by a post-war housing boom that reached some places and not others. The Delft team measured thermal performance in those households against comparable structures where the practice had lapsed. The households with continuous newspaper insulation showed overnight interior temperature retention averaging 3.8 degrees Celsius higher than the lapsed households, nearly identical to the 4.2 degrees the Aga Khan Development Network measured in Gilgit-Baltistan, measured on opposite sides of the world, in communities with no connection to each other, using the same cross-hatched folding technique, the same replacement rhythm, the same under-mattress placement logic, the same system, arrived at independently, preserved independently, performing identically. The Delft researchers noted something in their discussion section that deserves to be read slowly. They wrote that the Carpathian households had not preserved a folk belief, they had preserved a functional engineering solution. The distinction, they argued, matters for how we classify and transmit practical knowledge. One category gets studied, the other gets romanticized, and romanticized knowledge does not get replicated. That sentence is the clearest articulation of what this entire story has been building toward. The families in rural Pennsylvania in 1936 were not practicing folklore. The families in the Carpathian Basin who never stopped were not practicing tradition. They were practicing thermal engineering, without the title, without the credential, with the result. The bigger picture is this. We have spent the better part of a century building institutional systems for generating and validating knowledge. Universities, journals, certification bodies, building codes, and those systems are genuinely valuable. The 2017 Energy and Building Study is more reliable than any single family's experience. The Eindhoven University of Technology's 2021 Nairobi findings are more transmissible than word of mouth. Measurement matters. Documentation matters. But those systems have a structural blind spot. They are very good at creating new knowledge. They are not designed to recover old knowledge that was never entered into the record. Knowledge that lived in practice rather than in text. Knowledge that was too obvious to write down, too common to study, too present to notice until it was gone. The 1.6 billion people living in thermally inadequate housing, cited by the World Health Organization in 2023, are not waiting for a new material to be invented. The material exists. It arrives in their cities every morning. What they are waiting for is the method, the fold, the layer count, the replacement schedule, the placement logic. The complete system that the Carpathian Basin households never lost, and that the Aga Khan Development Network had to reconstruct from fragments before they could hand it to 47 households in Gilgit-Baltistan. The gap between the material and the method is not a scientific gap. It is a transmission gap. And transmission gaps are closed by exactly what is happening right now, by researchers who take practical knowledge seriously enough to measure it, document it, and hand it forward. That is what the Pennsylvania family in 1936 was doing every November, handing it forward. They just didn't know the chain would break. Remember the opening image, a family in rural Pennsylvania, 1936. First hard freeze, newspaper folded, layered, placed. They slept warm. At the time, that image reads as hardship, improvisation, making do with what was available because nothing better existed. It reads differently now. What they were doing was not a substitute for real insulation. It was real insulation, performing within measurement error of the fiberglass that would replace it 12 years later, solving the vapor barrier problem that modern building science still grapples with, delivering 3 simultaneous thermal mechanisms: trapped air, conductive resistance, partial radiant reflection from carbon black ink, from a material that cost nothing and renewed itself daily. The 2024 Delft University of Technology findings make that reframe definitive. 3.8 degrees of overnight temperature retention, measured in households where the practice never broke, confirms that what the Pennsylvania family was doing in 1936 was not approximate. It was not almost good enough. It was the solution. The same solution being piloted in Gilgit-Baltistan today, producing 4.2 degrees of improvement, being documented in journals, being translated into Shina and Burashasky, being handed to families who need it. The Pennsylvania family didn't know they were ahead of anything. They were just doing what worked. That is the reframe. Not that old knowledge was secretly sophisticated, but that sophistication was never the point. Function was the point. And function, it turns out, doesn't require a laboratory to be real. The research is still moving. The building research establishment at the University of Bath is currently developing a standardized assessment protocol for legacy cellulose insulation techniques, with publication expected in 2026. The African Center for Cities at the University of Cape Town extended their Khayelitsha field study through 2025, now tracking 43 households across 2 full winter seasons to establish long-term performance data. The Aga Khan Development Network's Gilgit-Baltistan pilot, which covered 47 households in its first phase, is being expanded to 120 households across 3 additional districts in 2025, with a formal outcomes report expected by the end of the year. Each of these programs is asking a version of the same question: how much of what was lost can be recovered, and how quickly can it travel to the people who need it now? The answers are arriving in increments: 3.8 degrees here, 4.2 there, 30% improvement from folding geometry alone. A maintenance cycle that changes everything. The system is being reassembled, slowly, carefully, with the kind of rigor that makes it transmissible to the next generation without requiring them to rediscover it from scratch. That work is ongoing, which means the story is ongoing. The newspaper under the mattress was never finished. It was only interrupted. The Carpathian Basin households studied by Delft in 2024 had been using the system continuously for over 90 years. 90 years of unbroken thermal performance, no certification, no R value label, no supply chain, just the fold, the layer, the replacement, the placement, the whole system intact. Still working, still warm. The research is still moving. The building research establishment at the University of Bath is currently developing a standardized assessment protocol for legacy cellulose insulation techniques, with publication expected in 2026. The African Center for Cities at the University of Cape Town extended their Khayelitsha field study through 2025, now tracking 43 households across 2 full winter seasons to establish long-term performance data. The Aga Khan Development Network's Gilgit-Baltistan pilot, which covered 47 households in its first phase, is being expanded to 120 households across 3 additional districts in 2025, with a formal outcomes report expected by the end of the year. What none of those program summaries capture is the secondary finding that has emerged quietly across all 3 research sites simultaneously, a pattern that nobody designed the studies to detect, but that showed up in the data regardless. In each location, Khayelitsha, Gilgit-Baltistan, and in the Nairobi informal settlement work that preceded both, households that received the full written protocol showed something beyond improved thermal performance. They showed knowledge retention. When researchers returned 6 months after initial instruction, households with written protocols could reproduce the installation method accurately in over 80% of cases. Households that had received only verbal instruction reproduced it accurately in fewer than 30% of cases. The degradation of verbal transmission, measured in real time, across 3 continents in 3 different languages, was nearly identical, roughly 70% loss within 6 months. The same rate at which the Pennsylvania knowledge degraded across a single generation. The same mechanism, different timescale, identical outcome. The finding has shifted how the University of Bath team is approaching their 2026 protocol. The original design focused on thermal performance metrics, how to measure whether a newspaper installation was working. The revised design, updated in late 2024 based on the cross-site transmission data, now includes what the team is calling a knowledge durability component, specific language, specific diagrams, specific mnemonics designed to survive verbal retelling without critical distortion. Not just instructions for how to install newspaper insulation, instructions for how to teach someone else to install it. The protocol is being designed for the first time to replicate itself, to carry the transmission mechanism inside the transmission, which is, when you think about it, exactly what a functioning craft tradition does, what Hanji construction does, what Ondel floor systems do, what the Pennsylvania families were doing every November when they showed their children, not just did the task themselves. The knowledge was never just in the newspaper, it was in the showing. There's a parallel development worth noting, one that sits at the intersection of the environmental story and the transmission story. In 2023, a team at the Wuppertal Institute for Climate, Environment, and Energy in Germany published a working paper examining what they termed embodied knowledge, the practical understanding embedded in traditional material practices that gets discarded along with the material when industrial substitutes arrive. Their analysis covered 11 traditional building materials across 6 regions, including cellulose paper insulation in Central Europe. Their finding was specific. The average time between industrial displacement of a traditional material and the point at which its embodied knowledge became unrecoverable from living practitioners was 22 years. Not a generation, 22 years. Fast enough that in many cases, the industrial replacement hadn't even been fully adopted before the knowledge required to use the original material correctly had already crossed the threshold of irreversibility. The Pennsylvania families who stopped being asked in the 1950s were already past that threshold by the time anyone thought to ask. The Wuppertal paper used a term for this threshold that has since appeared in the University of Bath team's revised protocol documentation. They called it the practitioner horizon, the point at which the last generation of active practitioners ages out of accessibility, not death necessarily. Retirement, cognitive decline, geographic dispersal. The practitioner horizon for newspaper insulation in the United States, the Wuppertal team estimated, passed sometime between 1968 and 1972, which means the Bressler Bulletin of 1955, even if someone had read it and acted on it, would have had only 13 to 17 years to find practitioners who could translate its measurements into operational method before that window closed. It didn't happen. And by 1972, the knowledge that remained was the artifact, the image, the habit, the vague memory, not the system. That is the number that reframes everything about the current urgency. 22 years from displacement to irreversibility. The newspaper insulation revival in sub-Saharan Africa and Southeast Asia is happening in regions where industrial insulation materials are only now beginning to displace traditional practices at scale, where the practitioner horizon has not yet passed, where the people who know how to do this correctly are still alive, still practicing, still accessible. The window that closed in Pennsylvania in 1972 is still open in parts of rural Kenya, in parts of northern Pakistan, in parts of rural Bolivia, but it is not open indefinitely. The same industrial forces that closed it in the United States are moving, slowly, but moving. The 22-year clock is running in each of those places, and the research programs currently operating in Khayelitsha and Gilgit-Baltistan and Nairobi are not simply studying a historical technique. They are in a race against a horizon that has already swallowed the same knowledge in other places. The urgency is not academic, it is calendrical. Each of these programs is asking a version of the same question. How much of what was lost can be recovered, and how quickly can it travel to the people who need it now? The answers are arriving in increments. 3.8 degrees here, 4.2 there, 30% improvement from folding geometry alone, a maintenance cycle that changes everything. The system is being reassembled, slowly, carefully, with the kind of rigor that makes it transmissible to the next generation without requiring them to rediscover it from scratch. That work is ongoing, which means the story is ongoing. The newspaper under the mattress was never finished. It was only interrupted. The Carpathian Basin household studied by Delft in 2024 had been using this system continuously for over 90 years. 90 years of unbroken thermal performance. No certification, no R-value label, no supply chain. Just the fold, the layer, the replacement, the placement, the whole system intact, still working, still warm.